section 3.3, our objective today is I can state and apply postulates and theorems about parallel lines. Now, yesterday we talked about two lines cut by transversal, or two parallel lines cut by transversal, then corresponding angles are congruent, alternate interior angles are congruent, and same side interior angles are supplementary, those kinds of theorems. Well, today we're going to use the converse of those theorems to prove that two lines are parallel. Okay, so our first theorem today is if two lines are cut by a transversal and corresponding angles are congruent. Okay, so you have two lines cut by transversal, and you know that the corresponding angles are congruent. Then the two lines are parallel. So the first way to prove that two lines are parallel is to find corresponding angles congruent. So if I have line L and line N, and I have line T, which is our transversal. And so if I can show that angle 1, or if I know angle 1 is congruent to angle 2. So this says if angle 1 is congruent to angle 2, angle 1 and angle 2 are corresponding angles, then I can say line L is parallel to line N. Okay? So the first way to show that two lines are parallel is to show that corresponding angles are congruent. The second way is to show that alternate interior angles are congruent. And this theorem says if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Okay, so again we have line L, line N, and we have transversal T, and angle 3 and angle 4 are examples of alternate interior angles. So this theorem says if angle 3 is congruent to angle 4, then line L is parallel to line N. So the second way to show that lines are parallel is to show that alternate interior angles are congruent. Okay? The third way is same side interior angles are supplementary. So the theorem says if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. Okay, so in this one we have two lines L and N, transversal T, and we have angle 2 and angle 4 are examples of same side interior angles. So if angle 2 is supplementary to angle 4, then L is parallel to N. Okay? Right, so that's the third way. Then, in a plane, two lines perpendicular to the same line, okay, and that same line would have to be the transversal, then the lines are parallel. Okay? So, have line L, line N, and, oops, transversal T. Okay? And L is perpendicular to T, and N is perpendicular to T. So if L is perpendicular to T and N is perpendicular to T, then L is parallel to N. Okay? And then the final one is two lines parallel to a third line are parallel to each other. Okay? So in this one we have three lines, L, M, and N. Okay? So if L is parallel to M, and N is parallel to M, then L is parallel to N. That's what it says. Okay? Alright, so examples. So I have this figure. This is E, F, G, H. And I know that this angle is 48 degrees and this angle is 48 degrees. So I want to know, can I say that I have a pair of parallel lines? Well, the only angle that we really know anything about is formed by, so this angle right here is formed by this line, oops, sorry, this line and this line. The other angle is formed by this line and this line, okay? And so looking at this, line HF would have to be the transversal. Okay, so we have EH and FG are two lines cut by a transversal, and this angle and this angle, in terms of those two lines, would be alternate interior angles, and so we know that those are congruent. So if we have two lines cut by transversal and alternate interior angles are congruent, then we know the lines are parallel. So we know that line EH has to be parallel to line FG. Okay? Example 2. Okay, this is point A, this is point B, point C, and point D. This is point G, F, and E. And I know that this angle is 53 degrees, this one is 44, this one is 53, and this one is 45. Well, looking at this picture, I see two angles that have the same measure. This angle and this angle. So let's look at what forms those two. So this angle is formed by this line and this line. The second angle, which is this one, is formed by this line and this line. So notice there that our transversal would be this line, okay? And then our two lines would be GB and FC. And this angle and this angle are, in terms of, they're above the transversal and both to the left of the lines. So those are corresponding angles. So I have two lines cut by transversal and corresponding angles are congruent. So the two lines must be parallel. So line GB has to be parallel to line FC. Okay, then let's look at this picture. So this is A, B, C. This is F, E, and this is D. And this angle is 5x plus 13. This angle is 6x plus 1. And this angle is 8y plus 3. Okay, and so I want to find the value of x that makes segment AE parallel to segment BF. Okay, so AE is this one, BF is this one. Okay, so then I could say then that this is my transversal, and so if that's my transversal, I have this angle and this angle, and in terms of the two lines in the transversal, those would be corresponding angles, and if the lines are parallel, then corresponding angles have to be congruent. So I can say 5x, whoops, I wrote 6. 5x plus 13 has to equal 6x plus 1 if those lines are parallel. So then I just solve for x. I'm going to subtract 5x. Get 13 equals x plus 1. Subtract 1. So 12 equals x. So the value of x that would make those lines parallel would be 12. Okay. Here's J, here's K, and this is 3x plus 10 and 5x minus 10. So find the value of x that makes J parallel to K. Well, if we want J parallel to K, then this is our transversal, and this angle and that angle are alternate interior angles, and if those lines are parallel, alternate interior angles must be congruent. So we would set 3x plus 10 equal to 5x minus 10. Subtract 3x, So we get 10 equals 2x minus 10, add 10. 20 equals 2x, so x would have to equal 10 for those to be congruent. All right, and let's look now at a proof. So given that angle 3 is supplementary to angle 5, prove that segment BD is parallel to segment FE. Okay? And so here's our picture. So this is A, B, C, D, E, F. Okay? And this is angle 1, 2, 3, 4, and 5. Okay? So we know that angle 3 and angle 5 are supplementary angles. Okay? And we want to prove that BD is parallel to FE. Okay? So we want to show that angle 4 and angle 5 are supplementary angles. That's our goal. Because if we can prove those are supplementary angles, then we can see that we will know that those lines are parallel. So number 1, our statement is angle 3 is supplementary to angle 5. And we know that because it's given. Okay? So supplementary by definition, then measure of angle 3 plus measure of angle 5 has to equal 180. And that's definition of supplementary angles. Okay? Then we need to get angle 4 in here somehow. And notice angle 3 and angle 4 are vertical angles. So we can say angle 3 is congruent to angle 4, or measure of angle 3 equals measure of angle 4. And that's by the vertical angle theorem, or vertical angles are congruent. Now I can substitute in place of this, I can put angle 4. So measure of angle 4 plus measure of angle 5 equals 180. That was by substitution. Okay? So therefore, by definition, angle 4 is supplementary to angle 5. And that is by definition of supplementary angles. And therefore, if I have two lines cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So BD is parallel to segment BD is parallel to segment FE. And the reason is if two lines cut by trans and same side interior angles supplementary, then the lines are parallel.